Hello again. Tonight we're going to talk about low-end amateur astronomy and the marketplace for those products, something I used to refer to as dirt cheap astronomy. And some things have changed recently that have made it bad. I was at Fern Forest Nature Center doing an amateur astronomy observing event for the public, and I brought out kind of my low-end, dirt cheap, no computers, no motors telescope, and everybody else was there with their $2,000+ more capable telescope with computer-controlled mount and automatically driving and such. So I said, well, let me look at the marketplace because I know some companies have come and gone and new kinds of smart telescopes have come in. So time to look at it again. And what we used to think of as the low end of the astronomy equipment marketplace is not what you think it once was. They're not there anymore. So I just described it as it's bad. So as I was saying, I was at Fern Forest. Most people were there with their $2,000+, and I would normally bring the same sort of rig, but I brought the low end because it was a clear South Florida evening, despite it being a light polluted suburban area where the park is. But the moon was there. Venus was there. Venus was a crescent. Jupiter was out. You could see the moons of Jupiter. Red Mars was there. And the bright blue-white star Sirius was there. So to line up my scope, I initially started pointing at Sirius. I brought one of my long tube doublet refractors. That's a long tube that has two lenses at the front, a little diagonal at the back, and an eyepiece. And if you get the math right, it's an 80 millimeter, about 3-inch diameter lenses at the front. It has a very long focal length. It's f11.4. And I put a 24 millimeter eyepiece on there, which gave me a field of view of about 0.8 degrees. The moon is 0.5 degrees. So this was a little larger than the moon. So the moon showed up pretty much filling the eyepiece. And I only had 38 times magnification, but that was more than enough to allow you to see like the moons of Jupiter and such, and to see that Venus was a crescent. So this rig was dirt cheap, but it was more than capable of showing what all we had to look at. But if I had to replace this rig today, it'd be kind of difficult to do. Not too long ago, there were other equipment manufacturers and suppliers that were available for you to buy low-end equipment from. Even Meade had a low end. If you were into solar observing with prominences and such, Coronado had HA telescopes that Meade acquired Coronado. And then you had Orion, which not only offered their own name-branded telescopes and supplies, but they would also resell other brands like Meade. And then Orion acquired Meade, but they're all gone now. They all folded up shop, couldn't make any money, and went away shortly after the pandemic. The only thing that's left that you can buy with those names on them now are inventory closeouts, because the original supplier of the equipment has shuttered their doors, laid off their staff, and not even providing repair parts if you have something that goes wrong. So if you owned a Meade mount and you found that something is malfunctioning in it, unless you find somebody who's clever enough and has replacement parts that can help you out, you basically have to buy a new piece of equipment, which is expensive. At the lower end, there were two companies that offered reasonably priced low-end products. That was Celestron and iOptron. But iOptron discontinued their low-end products, and Celestron took some of their low-end products and took parts off of them and then raised the price of them. So what used to be the reasonable low end is not there anymore. And you've got these things called smart scopes that are kind of learning their way into the marketplace. And then you've got the midpoint between the two, where companies like Celestron have taken what used to have a hand controller, and the hand controller is now gone. It supports Wi-Fi. Go load our app on your mobile device and subscribe to our cloud service. And yeah, it's there's no bottom end anymore. And I found out when the pandemic came through and it reduced the types of electronic components, the chips that were available, the fabs, the companies that make the chips, not to put the brand name on the chips or put the chips in the telescope products, but the companies that actually make the chip itself, they cut back. They said all these parts that are, 5 to 10 years old in design, we're just going to stop fabricating those. We're going to stop making those chips. And the way that the telescope makers used to make their margin is they would use obsolete chips, chips that were on like their last time buy, only available certain stocking sources. If you have a particular model of telescope and you only plan on selling 5,000 of them before it goes obsolete, then you just go buy 7,000 of these chips that are obsolete, no longer manufactured, and you're good to go for the life of that product. Well, when you run out of those and they're not making any more of them, you have to make a new design. And the designs for the electronics and the motors and such come from fixed term contracts. So you'd find that a company like Orion would outsource the building of a particular model of telescope to a third party that would design it, design the software and hardware electronics. They'd build it using the cheapest chips that were available at the time on fixed supply, obsolete, keeps the price down, and then that would be your inventory. But once those chips are gone, you can't build any more of them without redesigning it. And going and finding a new contract source, getting the contract started up again, getting new chips integrated into it, and getting all that supply line running again in order to produce the first unit of the replacement thing, it just proved to be too expensive, and the companies folded in on themselves because they couldn't afford to take the next leap forward. If you own one of these products and it's using obsolete components, maybe you can find somebody who would be willing to sell you for parts the same thing, but typically when parts per the design go bad, it's always the same circuit board or the same part. And unless it's a simple part like a coil or a capacitor or resistor, the more sophisticated, intelligent computer parts, they're not made anymore. So there are some people that have said, well, if you got all the electronics and parts out of the telescope mount, you can get my like open source based open computer design and replace the guts, maybe with changing some of the mechanics, and you can get your good optical telescope back online as a computer controlled telescope with some limitations. But if you find a bug in it, like get in line, I've got a bunch of people that have things that need to be fixed, or if you have a hardware design error, you got to wait for the next generation board to come out. So redesigning these things, getting them back into production is a giant leap up. Now, the optics, the lenses, mirrors, eyepieces, the Barlows, the field compressors, and the color filters and such, those are all pretty much reusable. So even if they have to do new computers and new motors and such, those are probably reusable. If the motors spin at the same speed, the gears and the worm drives, those are probably repurposable. But if you can't get the money together to contract out the software and hardware design for the electronics and computers, you have no product you can build. And if the number of companies that are building the products goes away, you can't even say, well, we're no longer making our own products. We're going to resell somebody else's product. But if there's nobody else to resell the product, you're kind of left with, there's no bottom end of the marketplace. They've taken some of these, what used to be the $500 to $700 range telescopes at companies like Celestron, and they've made them sort of smart. So instead of having a hand controller, they actually say, oh, it's got Wi-Fi. You just connect your mobile, your tablet, your phone up to it, and you download our app, and now you can once again command your telescope remotely using a device you supplied. Well, if the hand controller goes away, and to add one is going to be another $200 on the total cost of ownership, fine, you'll use your phone, because then you have to spend $200. But then you find out, oh, their app doesn't work on my older version of my iPhone or my Samsung phone. I've got to go buy a new phone device to be able to load their app to command my telescope. But the telescope costs you more money. So, the $500 telescope is now an $800 telescope or $1,000 telescope. And some of the functionality you used to do isn't available in their app. So but what you find out is some of these newer fangled telescopes don't do all the same levels of automatic or assisted alignment that the older telescopes could do. And, iOptron telescopes, for the most part, don't have a GPS in them anymore. So they couldn't do the course alignment. And basically, the bottom end of the marketplace has lost its smarts. At the next level up in price, there are these smart scopes. And these are typically not that cheap. They started out at the multiple $1,000 level and no hand controller. Once again, you're using your phone or your tablet. And think about it for a moment. That means if you don't have to have a hand controller, that means the manufacturer doesn't have to produce, a proprietary hand controller with the buttons and the display and the processor and the cord and the connectors and the wiring. They don't have to pay for that anymore. But the telescope costs more money. And then you look at, the actual telescope and the smarts of it, and they've outsourced all the innards of the telescope. And it doesn't have an eyepiece anymore. And how do you do alignment? They do alignment by plate solving. That basically means the camera that's attached to the computer associated with the telescope mount takes pictures of the sky and then says, what does that constellation look like? Let me get like a couple of points here. And now I know from that I'm, turned this way and lined up like this and tilted. And now it can line up on the night sky. But if the sky is not dark enough and it can't find enough bright stars to get its fix, it'll just say, alignment unsuccessful. And now what do you do? Well, you have to manually point the telescope and line it up. And then hopefully the telescope has a feature called sync, which is basically saying, hey, computer, trust me. I'm kind of in the ballpark of where I need to be here. And that's where I'm pointed. Okay. The optics in these smart telescopes are usually low-end optics. I mean, you don't find a 14-inch Schmidt-Cassegrain with these kind of smart capabilities in them because it's just going to add to the price even more. What you find is what would have been like an under $100 refractor telescope becomes the optical part of the smart scope. So why would it cost $2,000 for a 50 millimeter smart scope? Well, to pay for all the electronics and the curved, smooth plastic case that automatically tilts and swivels and has tripod legs that are custom, and it sits on a tabletop because it doesn't mount on a tripod, and all these things that have nothing to do with making a good telescope. They have more to do with the visual presentation of the product you bought, not with what you're looking at. And there's no ability to add things. Like if you don't like the camera they're using, you can't like take out their camera and put in a better camera or a different camera, kind of like you would if you were doing it with an older telescope where you get an eyepiece adapter, screw that onto the front of your camera and plop your camera in where your eyepiece used to be. Can't do that anymore because the eyepiece is gone and the camera is embedded in the telescope. Where's your focuser? Well, it autofocuses itself. And I found one of the telescopes that says, what, me focus? It doesn't focus. It just does everything as focused out to infinity. And then when you point at something that's smaller, it just crops the image. And if it's got an 8 megapixel camera, you're fine with, half a megapixel worth of actual image. So if you wanted to take a picture of something like, I don't know, the pillars of creation in the Eagle Nebula. Well, you could take a picture of the Eagle Nebula, but if you wanted to zoom in on the pillars of creation, there's no optical zoom because it's a low-end smart scope. It just says, well, you can crop it down until you can get the pillars of creation, and now your 8 megapixel overall image shrunk down so it fits the Eagle Nebula, and then shrunk down even further so it fits the pillars of creation, and you have, a 500 by 400 image. Is that what you thought you were going to get when you paid so much money for something that's smart? Don't think so. So the first thought I had was, if you want to make these mounts cheaper, less expensive to create a new low end, the first thing you need to do is stop embedding the battery in the telescope mount. by having to create a plastic enclosure for the battery so you can hide it inside so nobody sees it, and you make it a lithium ion battery that costs a certain amount of money and has a certain charge, and it has to be recharged and have battery management. And if you don't have battery management, the lithium ion battery is going to go useless after about 3 years. How about the first thing you do is you stop putting the battery inside the mount and just put a jack for the power source, and allow the owner of the telescope to maybe buy an optional battery, buy a battery from a third party, buy a bigger battery that sits on the ground and can run all night long, that kind of stuff. And typically the older telescopes use 12 volts DC as their power source, but a lot of things, and you've probably seen this in cars, are moving up in voltage to 24 volts or eventually 48 volts DC. This reduces a lot of the costs and wiring loading for the power. Strange as it sounds, you up the voltage, you're carrying the same amperage, and wattage end result is the same, and you can make the wires smaller. Even though the voltage is more, you can make the wires smaller in diameter. And also by being a higher voltage, if you want to move the telescope mount, you don't have to have as much gearing to take a high-speed moving motor to make it have a heavier torque to position the motor. You can use a higher voltage motor and less worm gear threads to move it with more oomph. And strange as it sounds, there's a thing called PoE, or power over Ethernet. And if you put an Ethernet jack on the mount, you can deliver data and power over the same wiring. And there are off-the-shelf, third-party power suppliers for PoE. By externalizing the battery and switching to 48 volts or PoE, now the customer can choose the right size battery they want. They can obtain whatever adapters they need if they want to run it on AC, or if they want to run it on a car battery. 12 volts, there are DC to DC converters. And by not having the battery inside the mount, if something goes wrong with the battery, there's no possibility that the battery going wrong, leaking, or fire can damage your telescope mount and your telescope. And if it does go wrong, it's easier to just replace the battery with a newer technology battery, because things improve over time, and keep the telescope. And migrate to industry open standards for the software and hardware designs. If every company that wants to build a telescope mount didn't have to reinvent the wheel or go contract out and find somebody that can design things for them, if they can use things that are already out there in the marketplace, that should reduce their cost. Also, if chips go obsolete and new chips come in, the open source could share the new design without everybody having to reset and everything be different. The actual astronomy coordinates, positioning routines, those are all open source. You can easily get those and just embed them in the mount of some Python scripting. And the libraries, the catalogs, the Messier objects, the NGC objects, all the different, 114,000 objects this hand paddle supports. Those are all open source. You can just put those in the software. And then if you want to build a more capable telescope, things like dew heaters, they're open source electronics and software for controlling heating. How do I know this? Because I also work with 3D printers and CNC routers that use mills and lasers, and they've already done this stuff. They've already created the open source commonized motor controllers and, steppers, and they actually have far more precise, sub-fractional millimeter movements than telescope mounts have. So it's not like their stuff will be worse because they're 3D printers. No, their stuff is actually going to be better. If you've ever seen the very large 3D printers, they can control very high current output capability. And my particular CNC router actually runs on 24 volts, not 12 volts. So they're already moving up to the 48 volts. And a telescope mount actually has fewer motors than a CNC router. A CNC router has to do X, Y, and Z, whereas a telescope has just got X and Y, altitude and azimuth, or RA and deck. Should be simpler. 3D printers have fewer heaters. A 3D printer has a filament heater to melt the plastic so it can make the 3D object. And it has a plate that it builds it on. And that's a plate that gets slightly heated so that the plastic will stay there and not move around. Telescopes have the telescope heater, an eyepiece heater, and a camera that might be a heater or a Peltier cooler, depending upon what you're doing with it. So the routines are already there. The electronic designs are already there. It's just a matter of adapting some of the software command structures to use solutions from other environments for telescopes. And the other thing is, years ago, telescope mounts had RS-232 asynchronous serial interfaces on them. And they made the giant leap forward and went with USB, which is also an asynchronous serial interface. But the connectors changed over time. They went from the A device end that looks like a little house shape to USB-C, looks like an oval, to different speeds and different voltage variants of USB-C. So now you have to get the right kind of charger for the battery that's built into the mount in order to do it. It's like, if you get rid of the serial port and you put in place, like, Ethernet, be it wireless or wired, that whole issue of what connector do we use this time goes away, because Ethernet's RJ45, the little clip plug, looks like a phone cord plug with more wires in it. That's been around for multiple decades. That's not going anywhere anytime soon. And since it can do power over that same connector, you can have one cable that will give you power and the data connection to your computer, your home network, to the internet. And instead of trying to come up with some proprietary graphical user interface that looks slick and fancy and a simple web server built into the mount electronics, that's easy to come by. It's all open source. The hand control of this just then becomes whatever device you want to use that has a web browser, a desktop, a laptop, a tablet, a mobile, and it's a web browser. So it doesn't have to be associated with an app that's specific for a particular model phone or particular version of OS running on a phone. It's easy stuff. How do I know that it's easy? Well, first of all, my career has been in computer software, so I know how easy it is to do. Secondly is I've actually worked on a project to do this with video. So I could put a camera on my telescope and then have people attending, the public observing, to just use whatever phone they got, fire up your browser, point to wherever the server is for the telescope mount, and pull up the current image, save it if they want to. No cloud required, no internet required. And as I was saying, no cloud required. The current generation of smart scopes requires you to download a proprietary app. You go to some public event out at a rural site in a dark sky. There might not be any internet access out there. There might not even be any mobile phone access out there. How do you get the app? Well, you had to know to download this guy's mounts app and that guy's mounts app, which are different apps, and have them all on your phone if you want to get an image from that guy's mount, and then walk over here and get an image from that guy's mount. The general public's not going to do that. The next thing is the public privacy concern. Oh, all you've got to do is download our app, and then to use it, give the email address and your name and maybe your mobile phone number to whatever cloud company is providing you with the app, just so I can get a picture of what you're shooting tonight, and I hope to never use that again. I'm not buying your telescope. I'm not controlling your telescope. I want to see a picture of what you're looking at. The public's not going to do that. If somebody says, download our app, oh, I'm sorry, your iPhone's too old. Your Samsung phone's too old. You should have a newer phone to use my telescope's app. Nobody's going to spend money to see a picture from your mount that requires a new phone. Alternatively, you can do what I did for a telescope mount, which was you put out a Wi-Fi access point, AP field, and you make it local. No internet access needed. You make the website for users read-only. You provide them a simplistic web page, no fancy, curved edge CSS, no dynamic client, anything. You just go to that public server, which is embedded in the mount, pull up current image. I can see every time it changes the image, it automatically updates because it's reading the web page again and again. And when it changes, I like that one. Right click or context menu, save image. I now have a copy of what we were looking at that event. Very easy to do. And it's pretty straightforward. So you don't have to do a lot of contract outsourcing to get this working. But then you have another branch of that same web server interface that does allow you to control your personal telescope. No cloud needed, no internet needed. And since it's all local, there's no internet security risk. So maybe to make it go even faster and less complicated, no Wi-Fi keys needed. You can still have individual device to browser interface isolated so they can't see cross traffic. That's easy enough to do. And no proprietary app, no cloud registration. It reduces the public use barrier. It reduces mount configuration because you don't have to go get an app to do this. And the processing would be far faster. You don't have to wait for, hey, I want to see the current image. Select current image. And you wait for it while the mount connects to the cloud and your browser connects to the cloud running their app. And then now you get the image and it will download. You can just see what the current image is. And this is my last issue. And I found this when I was looking at companies that were resellers of equipment from manufacturers. So whether you know it or not, most of the optical design elements are from Japan or Germany and increasingly from China. Most of the low-end equipment comes from factories that are in China. This is how they keep the prices low, actually keep the margins high. Prices aren't that low anymore. They only have what is known as just-in-time inventory. So they're not going to buy 1,000 telescopes from Celestron. They're going to buy 10. And when they sell out 8 of them, they'll buy another 10. Well, what that means is the price is going to change pretty radically if all of a sudden, oh, I'm importing this from China and it's, 10 to 100% import tariff. You're going to go buy something that you thought you were paying a certain price for. And then when it actually gets charged to your card, the price is significantly higher. Well, what they're doing to avoid that is they're buying almost no inventory as a reseller, and they're waiting for the number of orders to build up. So what you'll see when you go by a place like OPT and you say, hey, that looks like a really nice telescope at a good price. I want to buy that one. It's on back order. Well, when are you going to have it? Can't say, because what they're doing is they're waiting for the price to stabilize, and they'll buy a chunk of inventory at that price, and hopefully it will match the price that they thought they were going to charge you for. Orion used to be notorious for this. They'd advertise some accessory at $50, and you'd buy it before it's actually shipping. So they would take your $50, lump it up with a bunch of other people that want to buy the thing at $50, and then they just hold it there until they can get the part produced, get it shipped in an inventory volume out of China, and then they reevaluate their margin, the price. And then they'd say, oh, I'm sorry, we're going to have to cancel your order. I can't sell it to you at $50 anymore. We never had the product at that price point. I can sell it to you for $70. You want to put in a new order at $70? Because we're going to cancel your old order. That's kind of what's going to happen is you see these things that are back ordered. You place a preliminary order on the back order, and you think you're going to buy it at a certain price. And when the inventory comes in, it comes in at a tariff elevated price. And if that order doesn't get actually purchased in 30 days, the supplier is required to refund your money or cancel your order. So I'm seeing that a lot of these on back order things will either stay on back order until prices stabilize, or they'll go into a queue, and then you'll get told, well, we can't really sell it to you at the price that you committed to. Would you like to cancel your order or just pay the extra money? Well, they probably are willing to pay it at the price that you promoted it at. But if all of a sudden the price goes up by some variable amount, they're just going to cancel their order and wait until the prices come down again, which might be years, or at least a few years. So in summary, there used to be a quite vital low-end amateur astronomy equipment marketplace. You used to be able to go to your local Walmart and buy, a Celestron or a Meade or an iOptron low-end mount with telescope for, under $500. the manufacturers are gone. The suppliers have no inventory. Even some suppliers like Orion are gone. The models that are out there are in back order with no return date available. They used to sell reasonably priced products, and now they're only selling the higher margin items because they can make them and have the inventory. And the smart scopes still, for the most part, have low-end optics and low-end cameras and no hand controller. You supply the hand controller as your mobile phone, and don't make it too old one. You got to buy a new one. So the low-end market needs a new approach. They need to make modular designs. They need to share components across brands and manufacturers, maybe come out with a standardized model that can be plugged in as a unit. Central computer, the driver modules, the hand controller, all that kinds of stuff need to be standardized and learn from the 3D printer and the CNC and laser router marketplace. They've already got that covered. That's why they're so inexpensive. And at the low end, maybe lose the camera, go back to putting an eyepiece in because that reduces the total cost. You don't have to have a smart camera software if you have no camera, if you're just looking through an eyepiece. Bring back a hand controller, a unified hand controller that works across multiple models, and bring back the ability for the user to choose the power source, the battery, rather than making it a proprietary form factor embedded in the mount. And if people aren't familiar with the history and what happened and why they're gone of Meade, Coronado, Orion, and the notices of them ceasing operations as viewed from a third party, there's links to that. And the new so-called low-end GoTo scopes that don't have hand controllers, that are no longer dirt cheap, got some samples there from Celestron, iOptron, and Skywatcher USA. And then the marketplace of smart scopes, and they're rapidly changing. Unistellar brought out initial models, and they're now bringing out another generation called the Odyssey, and then a bump up pro version of that, the Vaonis Vespera, and now the Vespera 2, and the ones that are coming in at the, let's say, under $500 level are Dwarf and C-Star, which is actually ZWO. They're okay, but they're bringing out the even cheaper, the under $500 ones, but they're not shipping yet. So they need to get enough people placing orders for them someday soon in order for them to ship what they're advertising as the next best thing. But they've got the one that's, just under $1,000. You can buy one of those. And then you've got Celestron as the name of the manufacturer. So the Celestron Origin telescope mount. And that's, again, one that doesn't have a hand pedal and is a kind of smart scope. And so that's my take on the current amateur telescope marketplace towards the low end. The high end, you can still find stuff, and it'll do pretty much whatever you need it to do. But the low end is basically gone, and paying for a smart scope that's the better part of $1,000 that's got the optics of, an under $100 telescope doesn't make much sense. Okay. Comments, questions, alternative opinions?
So what's a fella to do?
I'm saying right now, don't. Your best approach is do people networking with your local astronomy group or observatory or university, find out where you can find an observatory that has open hours to the public or events to the public, and go look through somebody else's already existing telescope rather than trying to buy your own. Because buying your own right now, if you bought a smart scope, Unistellar for $2,000, and then all of a sudden Dwarf comes out with their Dwarf 3 for $430 and it's actually better, you're going to feel kind of stung. Or if you don't realize that it's doing plate solving and you say, I'm going to contribute, I'm going to take my brand new smart scope and I'm going to set it up at the public library so people going into and out of the library can look at the night sky. And then you learn that there are parking lot lights at the library that make it where the plate solving will not be successful. So how do you get the telescope to point? Yeah, you're going to learn a lot. Or you're used to buying, I've got a friend who owns one of the Celestrons from 15 years ago, and it works fine. I'll go buy one of those. Wait a minute, where'd the hand paddle go? Hand paddle no longer included. Give us another $200 plus and we'll give you a hand paddle. Otherwise, use your phone with our app. Oh, so yeah. What's a person to do right now? Don't buy unless you're buying towards the very high end. Lots of nice high end stuff out there, but be prepared to pay, close to $10,000 for a good telescope with a good mount and a basic imager.
What's going to motivate the companies to go back to having low end
Nothing,
astronomy?
nothing because their margin at the high end is quite high. And if they can design one telescope that sells for $4,000 and they get enough people buying it, they might not ever have to redesign that telescope or even tweak it for 5 to 10 years. They're going to be selling far fewer units, but the margin they're making per unit is considerably higher than the low end.
Okay. And I agree with that. However, it sounds like your presentation was being directed to an audience that might be motivated to do it. Who were you thinking that might choose to go back to doing certain things that you were suggesting?
iOptron is a company that came out of nowhere with their cube telescope mounts. And sure, they got a few things wrong in the early models, but by the time they came out with the Cube Pro and the Mini Tower Pro, they had a really nice, good price range of entry level mounts. They had a GPS in them. They were quick and easy to set up. You could use them at public events. They were really great. But the margin wasn't that great and they had to sell a lot of them. So what iOptron did is say, well, we're going to discontinue these products. We're going to sell ones that cost a couple of $1,000s for the same basic capability. We make more margin, we'll sell fewer of them. So they changed their business model. And what I'm looking for is the next occurrence of an iOptron kind of company comes in out of nowhere, makes use of the technology that's available, and builds a new baseline of low end, because you can't do it with the existing companies. They're too entrenched at fat margins to ever go back down to low end. But the one thing, and I actually talked to somebody at iOptron in their marketing department about 4 years ago when they discontinued the low end. And I said, if you discontinue the low end of easy to use mounts, you're going to make it more difficult for people coming into the hobby to want to contain and want to sustain their effort. If you say, well, you want that low end, go buy yourself a non-motorized mechanical mount that only does equatorial. So you're going to have to know how to line it up on Polaris and what right ascension and declination is. You got to know your local latitude, tilt the mount to that, and face it in the right direction. And you got to know all that in order to see the moon. That's going to turn people off from ever wanting to do it long enough to say, hey, I've been enjoying my inexpensive rig for a number of years now. My salary's gone up. I'm going to invest a little money in that higher price spread. So by gutting the low end, they're basically killing off the next generation of medium to high end hobbyists. So, will they learn their lesson? Only if companies come in and take the market from them, like Dwarf and like ZWO with the C star. They're trying to get a new low end, but only on smart scopes, only on these, like, people are so dumb that they can use their mobile phone and that's all they need to know how to do. You need to know a little bit more than that. Maybe not right ascension and declination or equatorial mount, because they're all altitude azimuth. But you need to know some basics, like that's a star, that's a planet, that's the moon. Don't point it at the sun. Well, the Dwarf 3 actually has 2 optical units in it and 2 cameras. And one of them, you can snap a solar filter on and you can actually do daytime solar imaging with your smart scope. Well, you have to know the difference between the two. Cover the nighttime camera and put the filter on the daytime camera, because the moon's a half a degree, the sun's a half a degree, and everything deep sky is tiny. Planets are tiny. So you need to know the difference between the different operating modes in order to make best use of it. So I think the smart scope environment is going to have a certain customer base, and then they're going to hit a ceiling. And that ceiling is you got to know how things work on a starship. And
Yeah.
if your entry level hobbyists can't be brought on board by making it simple, that's going to present a problem for the marketplace, and they're just going to have to learn.
Now, when you talk about someone trying to do the low entry, and
Mhm.
somebody here hears you tonight and says, "Oh, I want to do that," but you talk about low entry using technology that's already out there.
Yes.
Now, I know that in a lot of different areas, if you use somebody else's technology that's already out there, you got to pay a copyright fee or something, or they have some
You,
kind of patent on it.
you missed the part about where I said open source.
No, I heard about open source,
Yeah.
but are you just saying, so you're just saying limit it to open source for
Yes.
technology that's out there? Because there's a lot of technology out there that's not on open source.
Yes. And if you ever wondered why, if you bought a Meade LX200, and why did they never sell one of those things for under about $700? It's because every unit they sold, they had to pay intellectual license rights to Celestron for 2-star alignment.
Exactly.
Yeah. So that stuff's open source nowadays, because Celestron now does smart scopes and they don't do 2-star alignment anymore. No hand paddle. So yeah, there's a lot of stuff available in the 3D printer and CNC miller and laser routing marketplace that's available. There's a lot of Python libraries that are available for doing astronomical calculations. All that stuff's open source. In fact, the electronic circuit designs for moving motors and adjusting the temperatures of heaters, that's all open source as well. And the modules that you buy to do the electronics, you can go on Amazon and buy those in quantity, cheap. You can buy a 3D printer motor controller circuit module, and it's just like, it looks like a little chip that has a couple of components on it, and you plug it into a socket. And you can buy those things for $3 a piece, whatever quantity you want, because they're that cheap, because they're made in mass quantity, because they're reusable across the entirety of the low-end 3D printer market. So yeah, you've got to have a couple of people in your startup company that have some market savvy, as well as some software and hardware savvy, as well as some, business savvy. And somebody's going to come out of the woodwork and go, rather than fighting with competitors at the high end to just get my name out there, I can go in at the low end and just fill the gap that the other companies have left between the departures of Meade and Orion and the upward moving of Celestron and iOptron and those kind of companies. There's a huge financial gap that's there for novices. And you just have to create something that is capable at the right price point, but it doesn't have to be, with a camera built in and a battery built in, and it certainly has the ability to do those kinds of things.
Okay. Now, I don't think I don't know if I'll ever have a reason to go out, but I'm curious to
Mhm.
know, like, you keep talking about open source, and I've never been curious about it before, in the
Yeah.
sense like, well, okay, so there's open source on this and that and the other thing,
Mhm.
but how would I get to open source? I mean,
Okay.
is there
Open source is a generic reference to the intellectual property has been released for the public to be able to use with no licensing cost.
right? I understand that.
You may have to, in your software source code, say, "Hey, I got this from this guy, and here's the link to his site." There is places on the internet that you can go to. One of the biggest ones is actually owned by Microsoft. That they don't like to say it's Microsoft, but it's Microsoft. It's a place called GitHub, GITHUB. And you can go to GitHub and you can type in a search parameter and say, I'm looking for motor controls. And it will take you to a list of all the different GitHub like sub sites where you can go in and say, I want to look at the documentation, the installation, the actual source code. I want to be able to download for like, a Raspberry Pi, the actual working code for these modules. And then I can see if it's good enough to use, or maybe I'll tweak it, or maybe I'll go look at another guy's work based upon the same stuff and it's better. So, because
So you have to know that this site exists other than you can't type in, I want open source. There's nothing that's going to take you.
Oh yeah, sure. There's this thing called Google.
Yeah.
You go into Google and you type in open source. It takes you to a Wikipedia page where it describes everything about open source. And it will give you some examples. And one of the examples is GitHub. And then you go to GitHub and you say, what am I looking for? Telescope. Just go into GitHub and search telescope. And you'll find the hardware, the software, the astronomical algorithms. But now you're like, I don't know how to put all that together.
Yeah.
That's understandable. If you said, I don't like that cars cost so much money, I'm going to go build my own electric vehicle. Well, you could do that. There's a learning curve. There's a price for you stocking parts and stuff, and getting somebody to work with you on the software. So why would you go out as an individual amateur astronomer and try and build your own telescope when there are entrepreneurs out there that do have a little money that can say, well, how hard is it actually? Well, I found out that there's actually software and hardware called Captain. You can actually download Captain at a series of modules and hardware designs and build your own telescope mount. And then if you get it working, you can then like slap your company name on it and try and sell them and produce them in quantity. So there's the path. You don't really have to start from square one.
That's interesting.
Yeah. And that's, surprisingly enough, that's the same for anything. Anything that involves technology, if you said, well, that's a nice app. Are there any other apps like that? Well, you can go to an app store and you can find, 20 different things that are calculators. Why do you need 20 different apps that all do calculator? Because some calculators are better than others. Some calculators support like different units of measure, conversions, all that kind of stuff. That's why, the old style 4-banger app for a calculator it's sufficient, but it may not be sufficient for everyone. Same thing holds true with anything else involving technology. But I thought, I had put in the queue that I'm going to do a review of smart telescopes and give you some links to different brands and such. And I used to do every 2 to 5 years a dirt cheap telescopes update. And I said, past due, let me do one. And then I found all these warts to getting a dirt cheap telescope and said, well, next time I go to Fern Forest, I'm going to be schlepping out there the $2,000+ telescope mount because I can't show them my low end because you can't go buy it anymore. Doesn't exist. Can't buy it. Why should I tease them with something they can't go buy when I can tease them with something they can't afford? Now, somebody will look at my rig and go, how much does all this stuff cost? I said, well, my 150 millimeter Maksutov Cassegrain telescope now runs $2,100. Oh, I can't afford that. And my mount, my iOptron Cube Mini Tower Pro, iOptron no longer sells it, but they'll sell you an AZ Mount Pro for $2,500. I can't afford that. It comes with the tripod. The wheelie bar that I have on the bottom of it, I built that from some stuff I bought at National Tool. I bought a camera heavy-duty tripod, and then I put big knobby rubber tires on it. And that was probably about $400 worth of camera dolly. I can't afford that. I understand. I'm not showing you something that everybody should go buy one. Uh, I can't show you the low end anymore. So I'll show you what is really nice. And you didn't have to buy it. You just come out to the event and look through the eyepiece. But with these smart scopes out there, I'm gonna have to resurrect my camera scope where I have a visual observing scope piggybacked with a camera scope. And then the people that want to look through the eyepiece can look through the eyepiece. And the people that will see a pretty picture on the computer display, I can show them what's currently there, and they can use their mobile phone to just, connect to the Wi-Fi and grab a picture. Don't need an app for it. You can use a browser. So I've got to adjust how I'm doing public events in time for the June event at Fern Forest. So things change. The only thing that stays the same is the fact that things change. Okay, any other comments or questions before I stop recording? Nothing.